This is a high school geometry lesson in congruent triangles. Let's recall the definition of congruent triangles. Triangles are congruent when all corresponding sides are the same length and all corresponding angles have the same measure. Wait, that's like too much trouble. Last lesson we found a shortcut, one shortcut. We're going to talk about some more shortcuts today. The shortcut we talked about last time is if you have three set lengths, that there's only one way that you can put that together to form a triangle. So any ones that are made with the same length, side lengths, will be congruent. So when I take these and I put them together to make a triangle, this triangle is congruent to this triangle, even though it's crooked. If it's flipped over, doesn't matter. If it's the mirror image, doesn't matter. Why? Because the definition says corresponding sides have the same length and corresponding angles have the same measure. So even if it's oriented differently or reflected, it still has the same measure for all of those, and it's congruent. It doesn't matter that it's been translated or rotated or that kind of stuff. Okay, so one shortcut was if all the side lengths are the same between two triangles, they will be congruent. We call that the sides the same, the sides the same, the sides the same, or creatively, side, side, side. Okay. Another one for today is going to involve, so ones for today are going to involve some angles. Our first one up, I put these little triangles here to represent an angle that stays the same. The little blue triangle is the same. And then I'm going to have side lengths that are the same. So I'll start here, and I'll have my purple side length and my green side length. And I'm using the blue triangle there to indicate the angle that's between them. This is called an included angle because it's included between them. It has to be at the angle that's at the vertex formed by the two sides in question. So this is an included angle. That is a term of art that you need to learn. So if I have a side, then an angle that's included, then a side, and if I duplicate that over here, okay, I have my same length side purple, my same measure angle, and my same length side green. Question then is there any way that I can make these triangles different when I put the third side on? Well, let's try. Okay, if I come and I do that, okay, that makes a triangle. Pretty good anyway. All right, is there another way to do it here? Well, you know, I really don't care how long this orange side is. So if it were, you know, longer, I could do something like this. I could have this side. Okay, I think I'd like to try with this long yellow one and see if I can make a different triangle with that side, that angle, and that side. Okay, well, I'll put it here, and then to do that, I have to move the purple one to make it that length. And okay, I've still got the same side length purple and the same side length green, but uh-oh, the angle is different. In order to accommodate this longer yellow side, I had to open the angle up and make it a greater measure. So now this is no longer the same angle it is in the original one. It doesn't work. Okay, well, what if I wanted just a little bitsy piece to put right there? I don't have one, but if I had one, it'd be right there. Notice that the same thing happens. When I take a different length that's shorter, the angle that's included becomes smaller. So what we're demonstrating here is that to have two sets of corresponding sides that are congruent, that have an included angle, that's the same between two triangles, that the third side is going to have to be the same length, and they will have to be the same triangle. To show this up a little more formally, here is, I've demonstrated it, and then here is a postulate. We won't prove it, although we probably could. Go ahead and make note of this, pause it, and make note of it. Then the next item that we'll do is we'll say, let's practice a little bit of this and see when we can use this shortcut to decide if things are congruent. First off, are the top and the bottom triangles congruent? Well, let's see. There's only one pair of sides that's marked. But wait! Notice this stealth side here. The line segment BD is in both the top triangle and the bottom triangle. It's common to it. It's the same segment. When it's here, here, it's identity. Yes, okay, same segment. So that can also count as another pair of sides. The BD that's in the top one and the BD that's in the bottom one. So there are two sets of congruent sides, and there is an angle. Well, that sounds pretty good, doesn't it? Okay, so no, it's not. Why? Because the angle is not included. If we trace our pencil on this and say what it is, it would be side, side, angle, side, side, angle. It's not side, angle, side, because the angle is not included. These are not shown to be congruent. How about this one? Okay. Here we have, and I encourage you, when you do this, say it, maybe even out loud, and point to it with your pencil. That'll help you keep track of it. Okay, we have side, angle, side, side, angle, side. And also you have to make sure you say the sides in the same order. Like I started with side 2 marks, angle, side 1 mark. 2 marks, angle, 1 mark. Yes, these are congruent by side, angle, side. How about this one? Okay, well, we have our one set of sides that are marked as congruent, and we have a common side which will make another pair, one from each triangle. And we have an angle that's congruent in both of our triangles. Problem is, these ones that are marked are not the corresponding angles in their respective triangles. So it doesn't count for this purpose, even though they're the same length. In the right triangle, it's the hypotenuse. In the left triangle, it's a side. So, no, it doesn't work. How about this one? Are these shown to be congruent? Well, we got two pairs of congruent sides and an angle. That looks good. Oh, no. First, you got to do that next step. Is the angle included between the two sides in question? No, it's not. Side 1, side 2, the angle should be at T to be side, angle, side. Here's 1 and 2, and the angle should be at Q. So we don't have enough information to know whether this one is or not. It's not side, angle, side. It's side, side, angle. Okay? And if you say it and point to it, it'll really help you to make sure you get it straight. Okay, how about this one? Okay, well, I have angles, and I have a pair of sides on the top and bottom. Oh, yes, I also have a pair of sides here in the middle. The common side is in both of them. So I have side, angle, side, side, angle, side. And make sure you say it in the proper order. Okay, that's good. That works. Next one up. Let's try having two angles. Okay, we're going to have two angles, and we're going to use those. So we'll have a common side, two angles, and an included side. This time, the side is included, and it's going to stay the same. So I have an angle, and the included side. Then I'm going to make a triangle around that. Same deal over here. I'll have an angle, and the included side, and I'll make a triangle around it. So let's start here. There's my purple angle, my orange angle, and here are my sides that I'm going to make my angles with. Okay, here's the included side, angle, side, angle. Okay, so I need to make my red one at the proper angle according to my purple mark, and then the blue side at the proper angle according to the mark. So again, when I'm doing this, the green one is the one that has to be that length. The red and the blue, we don't care, just as long as it makes a triangle. That's all we care about. It's the angle, side, angle that we have that are going to be congruent, and those are the ones that we need to deal with to work with this. So angle, included side, angle, and I make a triangle that looks like that. Okay, I can do it again over here. I'll have my angle, side, angle, again the same length. I'll do my blue one first to make the angle there that's orange. And you know, I just really think it'd be nice if this would just go right like that and just touch at the end. That's how I'd like it to be. Because remember, I don't have any set length for the two sides that I'm not dealing with. So that'll work. That'll work on it. Oh, because I still have the same angle here and the same side. Oh, but look, this angle is not the same. When I made the red one more vertical, it's now a different angle. So now my two purple angles are no longer congruent. Okay? So that's not a good thing. Okay, so they're not going to be congruent. Well, is there any way to do it? What if I do it the other way? What if I put the red one to go with the purple, and then I just make this one, oh, I think it'd look cute like that. Don't you think that looks cute? Yeah, but it is cute, but it's not the orange angle. If I'm going to put the blue one at the orange angle, I'm going to get the same shape. It's always going to work out. Here we demonstrate that. And here is the statement of it for you. So pause for a moment and write this down. Angle, side, angle. And you can cite it as just ASA. Everybody uses this terminology. Okay? Now we'll look at another way with two angles. But this time it'll be two angles and a side. Okay? And the side will not be included. So I need to have these two angles. They might be that close or they might not be. And then this side. So angle, angle, side. Let's see what that'll look like. Okay, so I'll make my angle here with the side that needs to be at this green, yellow one. So that angle needs to be there. Okay, that one needs to be that way. Then over here, this angle needs to be right like that. Okay, so the two angles and the yellow side. The green side, we'll put this one together to make one side. The green side and the blue side don't matter. That's not part of our given. Our given is these two angles, not necessarily that close together, and this yellow side. Okay. Well, if I started, and so my question is, given an angle like this, and then a yellow side this length, can I make a triangle? Can I make two different triangles? Okay. So first off, I'll try to make a triangle. Let's see, I can, since the side length of the blue and the yellow, excuse me, the blue and the green don't matter, what I'll do is I'll just slide it up here right like that, and I'll see that that makes a triangle. Okay, that's a triangle, and so there is one. Now the question is, can I make others with the same criteria? These two angles, measurements, and this side length. Okay, well, I'll keep the angles the same, and I'll slide it along like this. Okay, well, the two angles are still the same, that one and that one, but notice that the length is not there. We're only using this much of the yellow stick. We have to use the whole yellow stick because that's a given, okay? So that doesn't work. So that doesn't meet the criteria of these two angles and that yellow side. Okay, well, what if I come back out here and make it long? Okay, I've got two angles and I've got the yellow side, but it doesn't close, so it's not a polygon. Well, I'll just pull that down like that. That'll make a nice little triangle. Oh no! Problem is, this is no longer the required angle. Okay, so if I keep that the required angle, I do it on the other side. Well, let's see. What if I wanted to do, say, like, you know, I wanted to make that be up there and touch. Okay, now my blue angle is the same, but my purple angle here on the left, I didn't preserve the angle that was required to be there. So what do I have a demonstration of here then? I have a demonstration that when I have these two particular angles, space between them doesn't matter, these particular angles, and this side length that's not included, that's not between them, then I see that this is the only way that I can make the triangle. Okay? So I hope you see that. That's a demonstration of it. There is one way and there is only one way. So that makes it a good theorem. Here is a statement of the theorem, so you can pause and write it down. Okay, now let's look at a few examples of this. Okay, first off, we'll have right here, okay, are these two triangles, can they be shown to be congruent by any of our shortcuts? Remember, if you don't have a shortcut, you've got to do all the angles and all the sides, and that's pain. So let's look for shortcuts. Do any of our shortcuts that we've discovered work here? Let's see. Okay, well, angle with a 1, angle with a 2, side. Angle with 1, angle with 2, side. Yeah, angle, angle, side, angle, angle, side. Again, I recommend heartily that you actually point to it, maybe even say it, and make sure that you're doing the marks accordingly. Like the first angle I said was the one with 1 mark, and then the second was with 2 marks. So yes, this is angle, angle, side. How about this one? Okay. Well, let's see. I have a side. I have 2 sides and an angle. That sounds promising. Oh, but wait, look. The angle is not the included angle, so that's not going to work. Won't work. Okay, how about this one? I don't have any sides marked as congruent, but I can be devious, I can be sneaky. I can see that this side here, the line segment RP, is in common. It's in both the upper triangle and the lower triangle, so there is one side length that is the same in both triangles. That'll be angle, side, angle, angle, side, angle. And notice I said them in the order by the number of marks on it. So yes, that one does work, angle, side, angle. So here's an example. It gets kind of messy. Yeah, messy example. Let's walk through it and see how we can determine. Okay, from all this mess, I want to know if you can determine these 2 triangles are congruent or not. So pause it and think for a moment. Okay, the 2 triangles are AFE and DFB, which is the bow tie. The 2 sides of the bow tie. Now notice that the markings that you have here, you don't have enough markings to do it, but you got to be sneaky, you got to be devious, you got to figure it out and remember everything you've done and use it. Well, why am I saying that? Because the 2 opposite here at the tie of the bow tie are vertical angles, and so they are congruent. Now when I'm working these kinds of things, I'll just go ahead and mark. I'll put 2 marks there, 2 arcs, so that I remember it. And so once you notice that you know enough from the drawing to do it, you'll see that it's side, angle, side, side, angle, side. And notice again, I said it in the order of the hash marks, the 1 and then the 2. Side, angle, side, side, angle, side. There was not enough information on this one without realizing that what's marked was not enough. Because when you read here the designation of what is corresponding by how it's written in the congruence possible statement, you can see that it's just not going to work. Okay? If you try to do it with what's here, you'll have angle, angle, you'll have side, side, angle, which doesn't work. Okay, next one up. Let's see if you can do this one. Pause it and try. Okay, this is angle AED, this big wedge, and then angle BDE, the wedge facing the opposite direction, kind of like an envelope without the top. So the 2 wedges, are they congruent? Well, let's see. At D, there's a right angle, so the other is also a right angle. So you have 2 right angles, and you have 2 angles up here at A and B inside the triangles. Okay, well that works. 2 angles. Do we have a side? Yes, we do. We have a shared side. ED is in both triangles, so we have angle, angle, side. Angle, angle, side. All right, try this one. Pause it a moment and try it. Okay, the two angles that we're dealing with this time are AED, the wedge on the left, BDC, the wedge oriented the same but on the right. What do we have on those? Well, let's see, both of them have a right angle, and both have a side that matches with 3 hash marks. So we have an angle and a side, but we need more than that. We need another side, or we need another angle. Oh, look, these are parallel. Those are parallel. That means this is a transversal of the parallel. And where there's a parallel and there's a transversal, there is, yes, corresponding angles. Right here, FDE and BCD are corresponding angles, so they are congruent. That gives us our other pair of angles that are congruent. So we have angle, side, angle, 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 side, angle. And so, yes, indeed, they are congruent. Okay, let's talk about what we've been doing here. We've been having lots of S's and lots of A's and all that kind of stuff. And sometimes they start spinning, and let's just talk about what we've had for our S's and for our A's. Okay, and so we started out with side, side, side last class period, and that worked good. Then today we did side, angle, side, angle, side, angle, and angle, angle, side. All of these show that triangles are congruent. Well, gosh, it just looks like we're making all kinds of combinations of S's and A's. So, what else can I think of? It's a okay, well, there's A. I wonder what that does. Okay, A. That's only the angles, all 3 angles being the same measure. Let's look at what happens on this. We kind of saw this was one of the things that we were already doing today. This has the same 3 angles as the smaller one has the same 3 angles. And so does the medium-sized one. They have the same angles. All 3 angles are congruent. But they are, but the triangles that I'm forming here, the little one, the medium-sized one, the big one, those triangles are not congruent. To get congruent triangles, angles is not enough. You're going to have a side length somewhere to be able to get it, to be able to do it. But notice that they are the same shape because the angles give us the shape. And so angle, angle, angle is not completely useless. It does show that it is similar. Okay? All right. So all of the rest of the combinations, the only other one I can think of is 2 S's and an A. So let's investigate 2 S's and an A and see how those work. I'll start with this right here. There's my dog. Okay. Is he gonna Okay, we'll give him a minute. Ollie. Okay, so I'm going to make triangles here. This is for my side-side angle to see if that'll work. So I'll start with this illustration. I'll have 2 sides and a given angle. And we'll see what we can do with that. I'll put the side down like that at the angle. Then I'll try to make a triangle. And I'm making this gray one at the bottom. That's the other side of my triangle. Okay, so yeah, I can make a triangle. There we go. Side, side, angle. Okay, well, is that the only triangle I can make with these criteria? Look what happens. I can swing this over here, and it touches right there again. Is it the same? Well, it's the same criteria. Side, side, angle are the same, but that is not the same shape of a triangle. Here, look again. Back over here. Green, blue, same angle. This way. Green, blue, same angle. Not the same triangle. 2 very different triangles. This one's a cube. This one's obtuse. Side-side angle doesn't work. This is why it doesn't work. Okay? There is, however, one exception, which is okay. Let's see how that works. Look as I swing it. Look what happens. It's because it touches it in two places. Here it's too long. In the middle, it's too long. So I move it back over here, and that works. I move it over here, it works. But all along in here, it's too long. What if it happened to be just exactly the right size? So here's the side-to-side angle. Side-side angle doesn't work. But what if I try with one that's just the right size? So if I have my blue one again, and now at my same angle, my same length blue side, but now when I swing it, it just barely touches. It just barely touches. So when I swing it here, it's not long enough to reach. When I swing it the other way, it's not long enough to reach to close to make a triangle. Only exactly there does it work. Okay, this is an exception. You're not allowed to call it side-side angle. You're not allowed to call anything side-side angle. That just doesn't work. We'll talk about that in a minute. Okay, but let's think back about this. What do you have here? You have a point, that vertex up there, and you have a line, the other side. So the distance between this point and the line, and this is the shortest distance. We just figured it out. Here's too long. All the different long ones. This is the shortest distance between that point and that line. And so we know from our previous studies that it's perpendicular. Okay? It is perpendicular. It is indeed. Okay? Perpendicular. That means this is a right triangle. So our exception to side-side angle is a right triangle. You're not allowed to call it side-side angle. What you call it is what the two sides are, the hypotenuse and the leg. And you can use it and refer to it as hypotenuse leg. And here is what that looks like, so that you can write down the formal statement. Okay, go ahead and pause it and write it down so you'll have it. Okay, let's go back to our list of all the S's and the A's. Now, you know, when I was taking geometry, I learned all these the same you did. This is what it's been for centuries, if not millennia, how people have referred to it. So I learned all the S's and the A's just like you're learning them. And when I went to start teaching geometry like 8 or 9 years ago, I said, oh yeah, the S's and the A's. And I remembered that all of the combinations of S's and A's work for something except one. I didn't remember which one it was, though. And so I had to sit there and fiddle with it and figure it out and say, oh yeah, it's SSA. But you know, all the time when I was taking in school and everything, and I had all these SSAs, and you know, I'd always have to go back and remember, well, which one is it? And I guess it says something about me that I never figured this out right here. And but I'll tell it to you because it'll help you to remember which one's the bad one that doesn't work. Okay, I refer to it as side-side angle, and that's how all of the math texts refer to it. But notice it would still be in the same order if you started from the other side and you called it angle side-side. Yeah, that's the one that's no good. And you may not use it. And you may not even say angle side-side. You can say side-side angle. But when you try to use this as a theorem, it's not a theorem because it's not true. When you try to use this as a theorem, it will make a donkey out of you. Okay? So it's the donkey non-theorem. Now, a word to the wise, don't get too upset. Y'all are all going to try to use it at one time or another. Okay? It's going to happen. You're going to work through this proof, and you're going to be working hard. You're going to be doing this and doing that, and you're going to come down and say, I got it. And then you look back and you see a side-side angle, and you go like, oh my, it done made a donkey out of me. It's going to happen. So just deal with it. Okay? Just remember, we'll call it side-side angle, and if you try to use it, it will make a donkey out of you. So don't even try. try to avoid it anyway. So, this one is no good. That's the only one that doesn't work, the only combination. Okay? Let's try a few examples. Okay, are these congruent? The left and the right of the bow tie. Well, what do we have? Okay, we know, all we know is those lines are parallel. They didn't give us very much. Okay, well remember, that makes that one a transversal, so we can get angles. We have not parallel lines and transversals, so we have alternate interior angles, so A and D are congruent. We can consider BE as the transversal, so now the angles at B and E are congruent. Hey, we've got 2 out of 3 angles congruent. What else can we get? Oh, look at the bow tie. Those are vertical angles, so they are also congruent. So we just got all of the angles congruent. We have angle, 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 but we don't have any side links. So we know that they are similar, but they are not congruent. We were asked if they're congruent, so the answer is no, they're not congruent. They're similar. We'll talk about similar later on in the course. They're similar, but they're not congruent because we don't have a side link. You're never going to be able to, angles kind of give you shape, and sides kind of give you size. You're not going to be able to get congruent unless you have some element that's size. One of the legs, you're going to have a side link to be able to get congruency. Let's see if we can figure this one out. Are the 2 triangles congruent? Notice which ones they're asking about. TUV, TWV, this arrowhead on the left. You look at that and you say, I don't have enough information to do that. And you don't. So you got to be sneaky. You got to figure it out. You say, well, I can't prove those congruent. Can I prove anything congruent? And yeah, you can. Look here. The top one and the bottom one, you can prove those congruent. How? Well, there's a common side. XT is common to both triangles, so you have side, 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 side. The top and the bottom are congruent. Okay, let's remember what that gets us. That the top triangle and the bottom triangle are congruent by side, side, side means they're congruent for all purposes. That means all of their sides corresponding are congruent, all of their angles corresponding congruent. Okay, now that'll help us because we have here the 2 little angles at T are corresponding angles from the big triangles, top and bottom. So the small angle at T and the small angle at T from the top and from the bottom are congruent, and that's the information we needed. So now we can say side, angle, side, the common one, TV, and side, angle, side, the common one. So we can prove them congruent based on what we have because they are congruent. Okay. Now, that I just talked about there, I talked about finding something else congruent and then using it. You're going to want to be doing that a lot when we're doing proofs and stuff, and I'm going to show you a way that you can refer to it that's handy. And what that is you can say corresponding parts of congruent triangles are congruent. Okay, now this is just another statement. This is just another statement of the definition, a restatement of the definition of congruent triangles. Okay? Well, then we'll say, well, why are you telling me this? Because there's a handy abbreviation that you're allowed to use. The first letter of each one of the main words. Corresponding parts of congruent triangles are congruent. you can use this as your reason and proof. And whenever you say, what's the reason? You can say CPCTC. Again, how is this used? Well, when you don't have enough information with what you have, if you can prove something else congruent by one of the shortcuts, once it's congruent by the shortcut, it's congruent for all purposes, so now you can use that, just like we used that in the previous one. So that works out to be a really handy thing to do. Okay, so a few more things here. How about this one? The overlapping triangles. The one up here, ACF, and the one down here, EGB. Pause it for a moment and see if you can figure out if those are congruent. And yes, they are. It's hypotenuse leg. You notice that they are both right triangles at C and at G, and then from that we have 2 marks in 2, 2 and 2, so we know that the hypotenuse of each is congruent, and the leg that we have is this one here on the top and the bottom. One mark each section, 1 mark each section, so the legs there are congruent. It's hypotenuse leg. They are congruent by that. Okay, look at this. Do you have enough information to say that these are congruent? Okay, well, I'm thinking not. I'm thinking if you think so, that you might gotten caught by that donkey theorem. Okay, looky here. Common side, side angle, side angle. No, don't let the donkey kick you. Don't let it make a donkey out of you. Okay. Okay, now for this one, you know this is the midpoint. Do you have enough to know that they're congruent? You really don't. You need to know you've got some side lengths. Oh, wait, I take that back. I just saw that. It'd help if those were parallel, but since you know it's the midpoint, you do have enough. You have angles here. The vertical angles are the same. Midpoint, definition of midpoint means it divides it into 2 equal segments. So this segment is the segment, same as that segment, and XZ is the same as ZQ. So you have side, angle, side. Side, angle, side. Make sure you write it in the correct order. Okay. And then one more. Let's see what we've got there. Do we have enough? Well, we have right triangles. Notice that the hypotenuse is 2 sections that are the same, 2 sections are the same, so a little segment addition will get us that NL is congruent to LS. And then, yes, indeed, we do have a leg. MN is the same as RL. So we have these are congruent by hypotenuse leg. So you should have in your supplies these 2 notes for your glossary. So go ahead and paste these in at the next available pages in your glossary, and here endeth the lesson.